Well, good morning. It's still morning. Okay, so this is Math 144 Practice Test 3. I've printed off a copy and I've written it all out ahead of time. So hopefully it won't take as long as the last one. That's what I want to say. I want to say you should work your own practice test. So go there. You can take it an infinite number of times, many times you like. Put your notes away and sit down, time yourself, work one out, and then you can focus on what you need to work on. Okay, so that's the best way to do it. So this is the first one here. We've got a right triangle with acute angle given right here. So they got the theta on the bottom left. Pay attention to where they got the theta, because sometimes it's up here and they try to confuse you. You want to have your theta down here. If you need to reorient the triangle, then do so. Now, for this particular problem, I want to point out that you could accidentally think that this is a 3, 4, 5 triangle, and it is not, because a 3, 4, 5 triangle has the longest side 5 on the hypotenuse. So if the 5 was up here, then it would be a 3, 4, 5 triangle, but it's not. So you want to be careful not to jump on 3, 4, 5, because that's not what this is. So what you need to do is you need to do the Pythagorean on this. You know, 5 squared plus 4 squared equals h squared, and then solve for h. And so you should get that h is the square root of 41. And now that you got all 3 sides, you can do your SOHCAHTOA. Okay, so sine of theta is opposite over hypotenuse. So 4 over root 41. Cosine is adjacent over hypotenuse, 5 over root 41. Tangent is 4 over 5. And then you've got your reciprocals, are just the reciprocals. Now, don't confuse reciprocal with inverse. These are not inverses. The inverse is where you trade the x and the y. The reciprocals are where you trade the numerator and denominator. So that's the big difference. Okay. You know, and kind of like when you're doing test 2, you like to write your stuff down, SOHCAHTOA, you know, write your stuff down, draw your triangles, just like you would for test 2, because these are cumulative. All right, so you'll notice this is not from chapter 3 or chapter 8, whatever it is. So there's that. Number 2 says, if theta is an acute angle of right triangle, and if cotangent of theta is the square root of 6, find the other trig functions. Okay. So here it is, cotangent of theta is root 6. So you can think of this as a root 6 over 1. The cotangent is the reciprocal of tangent. So that's going to be adjacent over opposite. And so now you can draw your little triangle, put your theta here. Adjacent is root 6, opposite is 1. And now you can use the Pythagorean to get the hypotenuse. The square root of 6 squared is just 6, plus 1 squared is 1, and that's 7. So h is the square root of 7. And here I just redrew the triangle with all our sides in there. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then you've got your reciprocals. And you don't have to write root 7 over 1 because it will mark it wrong. Don't do that. It's just root 7. Same with this one, that's root 6. And they even gave that to you in the beginning. Cotangent of theta was root 6. So I like to write them all out and then just be careful how you're typing it in. Make sure you're typing the right one in the box. Okay. That was number 2. Number 3. The point -6, -5 lies on the terminal side of an angle theta. Now you know, because the x and the y are both negative, that you're going to end up in the 3rd quadrant. But you don't need to worry about that. Just draw your triangle and leave the negative signs where they are. So -6, -5. This is the x, this is the y. Just draw your triangle. Here's the x, here's the y. And then use the Pythagorean theorem on it. So you should get 36 plus 25 is 61. So h is the square root of 61. And this is just me redrawing the triangle. And then you can just do your SOHCAHTOA. Sine is opposite over hypotenuse. And I like it this way because now your negative sign is built in. You don't have to worry about, all students take calculus, what's positive, what's negative in quadrant 3. So it's built in, -5 over root 61, -6 over root 61. -5 over -6 is 5 over 6. See, notice tangent is positive in quadrant 3. See that? And then, of course, you've got your reciprocals. Number 4. Find the exact value of tangent of -3 pi over 4. And we're going to answer all these questions here. It takes up that whole page. Number 4. Okay. So what we've got here, tangent of -3 pi over 4. So this tells me I'm going around in a negative direction. So we're going to go this direction, and we're going to go 3 pi over 4. Now I know going over to here is going to be pi. Pi is this over here. So -3/4 pi is going to go like this. It's going to land right here in quadrant 3. Your reference angle in here is pi over 4, because this is 3 pi over 4. Okay, so we're in quadrant 3. All students take calculus. Tangent is positive in quadrant 3. We actually even said that up here. So what that means is the tangent of -3 pi over 4. Well, that's the same thing as positive tangent pi over 4. So it's positive in quadrant 3, so you use a positive here. And then your reference angle is pi over 4. So this is equivalent to a positive tangent pi over 4. And now, what does my pi over 4 triangle look like? Well, it looks like this. And tangent of pi over 4 is 1 over 1. So that's just 1, a positive 1. Number 5. Number 5 says, determine the amplitude and range of the function y equals 8 sine x and sketch the graph. So here, y equals 8 sine x. So the only thing that's changing is the amplitude on this guy. You already know what the sine looks like. It looks like this curve. It's a positive sine x. So this is a positive sine x. Now, because of the 8, it's coming up to 8, and then it's going to come down to -8. And since nothing else has changed, this is 2 pi out here, and you can just keep cutting them in half or working it out. You got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So none of that changes. Your range is going to go from -8 to 8. I want to point out here the difference between A and amplitude. A is the number in front here. A is positive or negative. In this case, A is positive. But the amplitude is going to be the absolute value of A. And in this case, that's 8. So the amplitude is never negative, okay? It could flip the other way. If this was a -8, it would do this, right? And the amplitude would still be 8. It's just that A would be -8. Okay. And so here are the ordered pairs written out. So the only thing different is the 8 and -8. All right. Number 6. Determine the amplitude, range, and period of the function. Oh, did they want something else? Nope, that was good. Determine the amplitude, range, and period of the function y equals -3/2 cosine of 4x, and then graph it. Okay. So here it is. I know what my cosine looks like. My cosine generally looks like this, but because it's negative, it's going to flip on the x-axis. So it's gonna wiggle like this with that negative in front. So this is just showing you that reflection. Now the amplitude is going to be positive 3/2. So A equals -3/2, but the amplitude is 3/2. The period is 2 pi over b. B is 4. So that's 2 pi over 4, which is pi over 2. So what that means is this number out here is going to be pi over 2. Okay, that's this over here. So this is me filling it in now. The increments, so I'm draw my wiggle. I know I've got 3/2 and -3/2. I put my pi over 2 here. And now I know that these are 4 equally spaced partitions or increments. So we've got this increment. The increments, you can go pi over 2 times a fourth or divide it by 4. That's the same thing, and get pi over 8. So that means that each of these are worth pi over 8. So what I like to do is I like to take my starting at 0 and just go pi over 8 each time. So I go like 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, right? And this should reduce down to pi over 2, which is what you have over here. So this and this should be the same if you've done it correctly. And, and then you can just simplify them this way. And then you can look at your graph and see what the y values are doing. So here it's starting at -3/2, and then it comes up to 0, then it goes up to 3/2, and then it comes down to 0, and then back down to -3/2. So those are your quarter points. Number 6. So this is what it looks like. Oh, your range is -3/2 to 3/2. Now you're going to have brackets on these. So that means that it's going to include the endpoints. And there's the graph right here. So for this graph, you want to be looking for the correct wiggle. So this one's wiggling the wrong way. This one's a sine. This one's not even cosine. So A and B are out right away. What's the difference here? Well, the period on this is pi over 2, and the period here is 8. So, so this is the correct graph here. Number 7. Oh, this is a fun one. Okay, number 7 says, find the exact value of the following expression. And that's it. That's all they want. Okay. So now this is the inverse tan of -√3. So what I want to do is I want to know, what does this thing equal? So let's call it theta. Let's say this thing equals theta, right? You could think of this as the x thing and this is the y thing. And because this is the inverse, the x and the y are going to get traded. So this means that the tangent of theta is equal to -√3. You're just trading the x and the y. Now, because we had the inverse tangent here, that means we have the restricted domain. Theta on the tangent can only be between -pi/2 and pi/2. This is a restricted domain here. And if you think of it on the Cartesian coordinate plane, that's going to be in quadrants 1 and 4, like that. That's where theta is. It's here or there. Okay, you can't be over here or over there. So what do we got? Tangent of theta is -√3. So that means -√3 over 1. But or it's root 3 over -1, but it's negative. So the only way you can get negative, because tangent only lives in quadrants 1 and 4, that means quadrant 4. We're in quadrant 4. So our reference angle here, well, I know that triangle, root 3 over 1, that is your pi over 3 triangle. So your reference angle is going to be pi over 3. So we've got negative pi over 3, because our reference angle is pi over 3, and negative pi over 3 is in here. So theta is negative pi over 3. Number 8. Find the exact value of the expression. Inverse cosine of cosine 2 pi over 3. You know what I forgot? I forgot my formula sheet. Hi, I'm back. Anyway, don't forget your formula sheet. When you go to take test 3. Okay. Anyway, so we've got the inverse cosine of 2 pi over 3. So the first thing that I got to say is that in order for this to exist, the 2 pi over 3 has to be in the domain of this inner function, cosine, the restricted domain of the cosine. And that's exactly what they want here. So this is me trying to write it out. This is where you want to look. You want to look inside here and you want to say to yourself, what is the restricted domain of the cosine? And is 2 pi over 3 in there? So right there, the domain of the cosine of x is 0 to pi, right? Well, I should have brought markers for that. That's all right. So you might remember, it looks like cosine looks like this, right? But then it starts to go back up, so you have to stop. You can't, it has to be a one-to-one function for the inverse to exist. So it goes from 0 to pi. Okay, that's your restricted cosine. All right, 0 to pi. And then you got to say to yourself, is 2 pi over 3 in there? And the answer is yes. 2/3 pi is less than or equal to pi. So therefore, you can use the cancellation equation. So that means 2/3 pi, it comes right out. You just pop that right out. Oh, I did draw it down here. Right there. So this is what it looks like. If it's in there, then, it's like canceling each other out. That's why they're called cancellation equations. All right. That was number 8. Number 9. Get out of there. Find the exact value of the expression or state that it does not exist. So now I've got the inverse tangent of 4 pi over 3. So I got to say to myself, what is the restricted domain of the tangent function? So here it is. Shoot. Stupid arrow. So the domain of the inner function, well, that's just negative pi over 2 to pi over 2, right? What did that look like? It looks like this. You know, you've got asymptotes there. Here's pi over 2, negative pi over 2, and it wiggles something like that, right? So it looks something like this. That's your principal cycle. You know, and if you try to do any more, then it wouldn't be 1-to-1. So this is the restricted domain. So that's the domain of there. And we gotta say, is 4 pi over 3 in there? And the answer is no. So what we want to do is we want to evaluate this inner function. What is this? So because we're outside there, we want to know, you know, what is the point in here? What is the equivalent in here? So maybe it's over here. Maybe there's another wiggle out here outside, you know, and you want to get the one that's over here. Or maybe it's over here. I don't know. Anywho, so that's what we want to do. We want to evaluate the inner function. So this is me evaluating the inner function. Well, tangent of 4 pi over 3. Okay, so that's going to be 1 1/3 pi in a positive direction. We're going around. So this is 1 pi, and then we're going to go 1/3 more. So the reference angle is pi over 3. That's in here. And so this is equivalent to a positive tangent pi over 3. Tangent's positive in quadrant 3. So, oh, I know that triangle, and the tangent is √3 over 1. So this is equal to √3. Tangent of pi over 3, 4 pi over 3 is √3. And now you can just say, well, this equals inverse tangent of √3. Now that we've evaluated this, that's just √3. And then you can say, well, this is equal to theta. So tangent of theta is √3. And so that means then that, you know, we just did that. So that was the pi over 3 triangle. Ultimately, what might be easier is if you take that tangent pi over 3, right? Tangent pi over 3, if you put tangent pi over 3 in place of tangent 4 pi over 3, now this is in the domain of the restricted domain of the tangent. And now you can say cancellation equation, and then not worry about √3. So there's a couple ways that you could work it. All right. That was number 9. 10. Okay, we're going to rewrite the trig expression as an algebraic expression involving the variable u. All right, assume that u is positive and the value of the inner inverse trig function represents an angle such that theta is between 0 and pi over 2. Okay. Okay. So here's the problem. Now what I'm going to do is I'm just going to call this guy theta. Okay, just call it theta. So inverse cosine of 9u is theta. That means then that the cosine of theta is 9u. 9u over 1. We can say that's adjacent over hypotenuse is the cosine. So here's my triangle. I've got, here's theta, adjacent is 9u, the hypotenuse is 1, and so we can call this y over here. So let's solve this for y. We've got 9u quantity squared plus y squared equals 1 squared. And we're just going to solve that thing for y. This is going to be 81u squared. And then you can subtract that over from the 1 and then do the square root. And that's all you're going to do with it. Don't try to simplify that. It cannot be simplified. Okay. I see people all the time try to do, you know, 1 minus 9u or something like that, you know. But you need 2 things in there in order for it to come out, you know. And It's actually a difference of squares. This is a 1 minus 9u times a 1 plus 9u, and those two things are not the same. So I don't have two of the same things to come out. So don't try to simplify that thing. Okay, so this is what the triangle looks like now that we've figured out what y is. And now the tangent, because we wanted to find tangent of theta, the tangent now is going to be opposite over adjacent. So there's your answer. Number 11, complete the reciprocal identity. So I've got a question mark equals 1 over cosecant. Well, this is one of those things I like to write on my paper when I'm testing. Sine is opposite over hypotenuse, you know, and etc. And then these are the reciprocals. So I'm looking for the reciprocal of cosecant. Well, the reciprocal of cosecant is sine. So sine of theta is 1 over cosecant. Being playful. Okay, number 12, complete the Pythagorean identity. 1 plus blank is cosecant squared theta. Well, sine squared plus cosine squared equals 1. Okay, so we're going to take that basic one and then just divide everything by sine squared. And that's going to get me the identity that I want, you know, and if it got you the wrong one, you can divide everything by cosine squared, and then you'll get tan squared plus 1 is, I forget, what we're doing, cosine is secant squared. So, you know, that's how that would work. But this one, you divide by sine squared, you're going to get 1 plus cotangent squared equals cosecant squared. And so that's what you can put in there. All right. Number 13, find the exact value of the trig expression, cosine of pi over 3 minus pi over 4. Okay, so we could fill all this stuff in. 13. So this is where the formula sheet comes in. Okay, you're going to use your formula sheet. You can label this first one alpha and that second one beta. So I'm going to look for cosine alpha minus beta. So cosine alpha minus beta is right here. And that's cosine alpha, cosine beta plus sine alpha, sine beta. So this is straight from the formula sheet. So I just gotta figure out what does my pi over 3 look like? What does pi over 4 look like? Well, here's pi over 3. And I might as well find the sine and cosine because I'm going to need both. So sine is going to be root 3 over 2. Cosine of pi over 3 is 1 over 2. And then the pi over 4 triangle, they are both 1 over root 2. 1 over root 2, 1 over root 2. And now it's just a matter of filling it in. So cosine of pi over 3 minus pi over 4 is cosine pi over 3 times cosine pi over 4, because this is alpha, this is beta, plus sine of pi over 3 times sine of pi over 4. It's just per formula. And then you can just fill it in. And some people have trouble with the math here, but you're just multiplying here. This is 2 times root 2 in the denominator. 1 times 1 is 1. And root 3 times 1 is root 3. 2 times root 2 is 2 root 2. Now, they have the same denominator, so just write it as one fraction. This is 1 plus root 3 divided by 2 root 2. And that's that. Number 13. Number 14. Okay, so this is going to be another formula sheet problem. Number 14. Find the exact value of the following trig expression. So this time our alpha is 5 pi over 4 and our beta is 7 pi over 6. So what we're going to do is I drew my triangles up here just so I can look at them. I'm going to look at alpha first. 5 pi over 4, that's like 1 1/4. So I go around, it's 1 pi and then 1/4 of pi. And sine, all students take calculus. So sine is negative in quadrant 3. So this is equivalent to a negative sine pi over 4. Sine of pi over 4 is 1 over root 2. So this is negative 1 over root 2. Cosine of 5 pi over 4. All students take calculus. Cosine is also negative in quadrant 3. So that's negative cosine pi over 4. And that's going to be a negative 1 over root 2. And now we can do the same thing with 7 pi over 6. Beta is 7 pi over 6. So I've got pi, and then I've got a 1/6 pi more. So now this is my reference angle. And again, sine and cosine are both negative in quadrant 3. So this is negative sine pi over 6. This is negative cosine pi over 6. So negative 1/2, because you're on the pi over 6 triangle now. 1 over 2. And then the cosine is root 3 over 2 with a negative. So there, I've got all 4 of these. And now I'm just going to use my formula sheet for the sum. Right, I've got the sine of alpha plus beta. That's what I've got. I've got this one right here. The sine of the sum. Okay, so sine of alpha cosine beta plus cosine alpha sine beta. And I've written it out here. And I just went sine of alpha cosine beta plus cosine alpha times sine of beta. So this is going to be a positive root 3 over 2 root 2. This is going to be a positive 1 over 2 root 2. So root 3 plus 1 over 2 root 2. Number 15. Okay, number 15. You know, you're going to notice that these two are the same. And so let's just call it theta. So 2 sine negative pi over 6 times cosine negative pi over 6. So we're going to use the formula sheet. Number 15. So you can think of it as 2 sine theta cosine theta. So if you look on your sheet, we got 2 sine theta cosine theta right here on the top of your double angle formula. So this is going to be sine of 2 theta. And theta is negative pi over 6. So we're looking at sine of 2 times negative pi over 6. And you could simplify that to a negative pi over 3. So elementary, we just go negative pi over 3. Looks like that. All students take calculus. So sine is negative in quadrant 4. And so sine of negative pi over 3 is negative sine pi over 3. You know, also want to point out that sine is odd. You could just throw that negative in front. That's another way to think of it. Cosine's even, so that doesn't work. Okay, negative root 3 over 2, you'd actually go with it. So we're just looking at pi over 3. And that's opposite over hypotenuse root 3 over 2, and it's negative. So there it is. Number 15. So that's what it looks like. You type in. Oh, this is a fun one. Actually, this one wasn't as bad as I thought it was going to be. -9 cosine squared, and you want to write it only raised to a power of 1. So you're gonna do the power reduction formulas is what that is. And number 16. Okay, so on the formula sheet, we've got your power reduction formulas here. We've got cosine squared is 1 plus cosine 2 theta over 2. Okay. Now I like to just take that 1/2 and bring it out in front while I'm working. Also note that this is an X, it's not a theta. I see students do that all the time. They accidentally put a theta in the answer and it's marked wrong. So be careful there. Replace the theta with the X. Okay, so I've got -9 cosine squared X, and I'm using this formula here. This is -9 times the half times 1 plus cosine of 2x. I just went and made that an x. Okay, that's all I did. And then this is just -9 over 2. And now I'm just going to distribute the -9 over 2. See how easy that was? That was easy, actually. -9 halves minus 9 halves times cosine of 2x. Make sure you don't put theta in there. So easy to do. Okay. So that's what the formula is. Number 17. Are you going down the home stretch? Yeah. Oh, these ones. These are kind of interesting. They took a whole page for number 17, though. All right. Suppose that tangent of alpha is 15 over 8, such that alpha is between pi and 3 pi over 2. So what does this mean? Between pi and 3 pi over 2. All right, that means, here's pi. Where's pi? Pi is over here. And then 3 pi over 2 is down there. So that means it's in quadrant 3. All right. That means the x and the y are both negative. So essentially, it could put a -15 over -8. That's really what that means. Now we want to determine the value of sine of alpha over 2. So, but now be careful. This is not asking for the quadrant of alpha. It's asking for the quadrant of alpha over 2. Okay. Okay. So here's alpha. We're just investigating alpha for a little minute. Okay, 15 over 8 such that alpha is between pi and 3 pi over 2. So that puts us in quadrant 3. Alpha is in quadrant 3. Tangent is -15 over -8. So this is what the triangle would look like for alpha. Okay, you've got your x and your y, and your hypotenuse then is going to be 17 when you use the Pythagorean on it. We will need this later. We're going to want the cosine of alpha later when we want to plug it into the formula. Okay, so now we want to find the sine of alpha over 2. Oh yeah, and if you think these are big numbers, you know, negative 8 squared, 64, 15 times 15. You should be able to just, you know, scratch that out. 5 times 5, 25, 5, 75, and then 15, and then add. And then if I add 64 to that, I get 289, and I do recognize that 17 times 17. But if you didn't recognize it, you could do 17 times 17. You know, it's more than 15. So try 16, that didn't work. Okay, try 17. So, you know, if you need to do the longhand on that, go ahead. But anywho, we're going to need this later. So cosine of alpha is negative 8 over 17. Now they want us to find sine of alpha over 2. So I'm going to take that inequality that they gave us up here, and I'm going to times everything by a half so I know what's going on with alpha over 2. So this is going to be alpha over 2 now is between pi over 2 and 3 pi over 4. Well, where is that? That is quadrant 2, right? This is pi over 2. Pi over 2 and 3 pi over 4. That's less than pi. So it's in between in here, right? That's in here somewhere. Alpha over 2. So alpha over 2 is in quadrant 2. So I'm looking at my formula sheet now, and we want the sine of alpha over 2. Sine of alpha over 2, right? And we want to know alpha over 2 is in quadrant 2. So that means I'm going to use this first one here. Okay. Notice that this is the same. The only thing that's different is the sign. Look, this is positive, this is negative. When you think about what quadrant sine is positive in, sine is positive in quadrants 1 and 2. All students take calculus. Sine is negative in quadrants 3 and 4. That's why this is written out like that. The only thing different is the sign, because sine is positive here and here. Sine is negative here and here. But this radical is the same radical. So anyway, I just wanted to point that out to you, because it looks complicated, but it's really all about, you know, sine being positive or negative. Okay, so from the formula sheet, we got alpha over 2 is in quadrant 2, so we're using the positive square root here. And we're going to need the cosine of alpha, and we figured that out up here, negative 8 over 17. So we're just plugging that in. 1 minus a negative, so that's a 1 plus, right? 1 plus, so I get a plus here. Now, if I multiply the numerator and the denominator by 17, I would have to distribute that here, see? So 17 times 1 is 17. 17 times this fraction, the 17s cancel, and I just get the 8. And then 17 times 2 is 34. So that's how that works out. And then you get the square root of 25 over 34. And that's going to be 5 over the square root of 34. And you don't have to worry about trying to rationalize the denominator. This thing does not simplify because that's just 2 times 17. So there isn't any simplifying that. All right. That was 17. And this is what it looks like. So alpha over 2 is in quadrant 2. The sine of an angle. Well, sine is positive in quadrant 2. I think that's what we wanted. And then we got the right formula. And then you gotta make sure that you're clicking in the right one when you're typing that in. Okay. Number 18. Determine a general formula or formulas for the solutions to the following equation. Okay, so sine of theta equals 1 over 2. And then, of course, we want specific solution on 0 to 2 pi. 18. Okay. So when I think about sine of theta equals 1/2, well, sine is positive in two different quadrants. So sine is positive in quadrant 1, but it's also positive in quadrant 2. So if you think of the variations there, we've got opposite over hypotenuse. So opposite over hypotenuse, this is going to be the pi over 6 triangle. I recognize that. So my reference angle is going to be pi over 6. Now pi over 6 occurs here. The reference angle in quadrant 2 would be over here. So both these two angles, you've got pi over 6, and you also have 5 pi over 6. Now, if I take this pi over 6 and add 2 pi, I'm going to land in the same spot. So we want to get that general formula. So I add 2 pi, and then another 2 pi, and another 2 pi. That's 2 pi k when k is an integer. So I have pi over 6 plus 2 pi k. That's for this angle. Now for this angle over here, that's 5 pi over 6. So you go 5 pi over 6, then you add 2 pi k. So you add 2 pi and 2 pi or 2 pi, you know. And that could be negative too, going the other direction. That's where you're landing. So there's the general formulas. Now, if you just want the angles that are between 0 and 2 pi, well, these are them, pi over 6 and 5 pi over 6. That's it. Let's see. Number 19. Okay, so we got another one of these. Sine of alpha, or I'm sorry, theta over 2 equals 1. So sine of alpha over 2 equals 1. All right. So 1, you could think of 1 over 1, and then you've got, if you think of 1 over 1, opposite over hypotenuse, then, it's like there is no x because these are the same distance. It's like that. So, but you could also think of it on the unit circle, if you will, and I like to have these points out just for fun. And if you think of the x is the cosine and the y is the sine, because you know that triangle, right? Everything's about triangles, right? This is t, this is x, this is y, and this is 1, right? Then, cosine is x over 1 and sine is y over 1. So then if we want the sine, well, that means we want the y coordinate. So that means then, well, where is the y coordinate equal to 1? Well, that occurs right here at this ordered pair 0, 1. And so from here to here, that's pi over 2, right? So because here to here is pi, so this is pi over 2. So that means that sine of theta over 2 is 1 when theta over 2 equals pi over 2. And then, of course, if you go around again and again and again, that's 2 pi k. But now this is for alpha over 2. We want to figure it out for alpha. So we got to get rid of this 1/2. So what we're going to do with this general formula is multiply everything by 2. So I'm going to multiply this by 2, that by 2, that by 2. So I'm going to get theta equals pi plus 4 pi k. And that's going to be your general solution. Now on 0 to 2 pi, then you want to have, okay, you've got, if k is 0, then you just got theta is pi. If k is 1, then you've got 5 pi, right? Or -1, then you've got 3 negative 3 pi. So these two are not going to work, and so this is the only one that is going to be between 0 and 2 pi. So you're going to pick, you can use the general formula to figure out which ones are inside that interval. Okay, that was 19. There it is. And now for number 20. Ah, yeah, this one took a picture. Okay, this is a lengthy one. Determine a general formula for the solution to the equation, and then we want to get the specific solutions between 0 and 2 pi. Okay, so we have 4 sine to the 4th minus 7 sine squared theta plus 3 is 0. So what I'm going to do is I'm going to use a u substitution for this one. So if u equals sine squared theta, then u squared is sine to the 4th, right? I could even write that there. U squared then is sine to the 4, sine of theta to the 4. This is the same thing as sine squared theta squared. Okay, whatever. Anyway, so that means I've got 4u squared minus 7u plus 3 is 0. And it's just a matter of quick factoring. Maybe you like the AC method. These are the middle terms. If you do 4 times 3 is 12, and then the factors of 12 are 3 and 4. I know that's pretty silly, but there it is. But I just went 4u times u is 4u squared, and now it could go 3, 1 or 1, 3. This is prime. And then, so I get the 3 this way and a 4 that way. They got to add up to a negative 7. And they're both negative because negative times negative is positive. We get negative 3u minus 4u adds up to negative 7u. So there's your factoring. And you can set each factor equal to 0 because you're solving. So I don't know which one to do first, really. I guess it doesn't matter. So 4u minus 3 is 0, or u minus 1 is 0. So let's go ahead and do this one first, I guess. So I'm going to just solve that and get u as 1. And now once I solve these things for u, I can put the sine squared back. So if sine squared is u, then sine, I did the square root. Sine is plus or minus the square root of 1. That's a square root property. And so that's just plus or minus 1. So now, like we did on that other problem, you want to think, well, where is the sine equal to 1 and where is the sine equal to negative 1? And remember, the sine was the y coordinate, right? So we want the y coordinate to be 1 or negative 1, and that's here and here, right? So that's going to be at pi over 2 and then at 3 pi over 2. That's where you're going to get sine as 1 and sine as negative 1. So theta is pi over 2 and theta is 3 pi over 2. So that's this part. Now, if I took that pi over 2 and then I added a pi, I'm going to get this one. And then if I add another pi, I'm going to get that one. And every time I add a pi, I'm back at the other spot. So what you want to do is you can write pi over 2 plus pi k. And that's just going to cycle back and forth between those. So this is one general form that you're going to need. A similar thing is going to happen on the other side with this one here. So I have 4u minus 3 is 0. So u is 3/4 when you solve that for u. Put the sine squared in there. Sine squared of theta is 3/4. And now you can do the square root. So sine of theta is plus or minus the square root of 3/4 or plus or minus root 3 over 2. I'm sure you recognize that triangle. That is going to be the pi over 3 triangle. So this, and since it's plus or minus, you're going to get that in all 4 quadrants. Okay, so you got your reference angle in all 4 quadrants. Because sine is positive here and here, sine is negative here and here. So you got to go all 4 quadrants. Now, root 3 over 2, opposite over hypotenuse is pi over 3. Okay, so we got pi over 3 here in the first quadrant, but if we add pi, we're going to get this angle over here. So I'm just going to go pi over 3 plus pi k. That's going to get me both of these. It's going to cycle from here to here and then back to here like that. Now, the other one here that I have written in blue or highlighted in blue is, this is 2 pi over 3. To get from here over to here is 2 pi over 3. And then if you add pi, you're going to get the other one over here. So I'm going to add pi and I'm here, and I add another pi, I'm there. So, you know, that's going to cycle pi, 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 pi. So we have pi over 3 plus pi k gets these two. And then we have 2 pi over 3 plus pi k gets us those two. So there's actually 3 of these going on. You've got these two and those two. Also, this is a pretty silly thing with the program. You might say, oh, what's wrong with my answer? You want to make sure that the smallest angle goes in the first box. It goes smallest to biggest. So which one's the smallest? You know, this one's the smallest, right? Pi over 3, and then pi over 2 and 2 pi over 3. Right, so it's this one, and then it's this one. So this one first, then that one, then that one. Okay. Now you want to say, well, what are the angles on 0 to 2 pi? Well, we've got the pi over 3, and you can even look at this to figure it out. You got your pi over 3, then you've got pi over 2, then you've got 2 pi over 3, then you've got, oh, not that one, this one, 4 pi over 3, then you've got this one from over here, and that's going to be 3 pi over 2, and then you've got this one here, and that one is 5 pi over 3. Because all the way around would be 6 pi over 3, which is 2 pi. See, so that's 5 pi over 3. All right, and if you need to do a little bit of scratch work, I got some scratch work down here, figuring out that angle. Okay. And that was the last problem. So I hope that was useful to you. I don't know who's watching this, but I hope you have an enjoyable day, and good luck on your test. Let me know if you have any problems, any questions. Let me know if your proctor needs the formula sheet. So make sure you email me, and I will send it to them and let them know. Okay. Have a good day.